Before starting the next lesson, try this warm-up. Pause the video and see how you do. So if you'll recall, rate of change is rise over run. So on this graph, the rise is 300 kilometers and the run is 5 hours. So you have to pay attention to the scale on each axis. So rise divided by run, 300 divided by 5 is 60, and it's kilometers divided by hours, so it's kilometers per hour. So 60 kilometers per hour is the rate of change. And what does it mean? Well, it means a speed. This is the speed. In this lesson, we're going to talk about something called slope, and you've pretty much seen it before. I'll get into detail, but we're looking at finding the slope from a graph or a table of values. So the steepness of a line segment is measured by its slope. So that's what we're talking about today, is slope. It is calculated the same way as the rate of change. So in the warm-up, you calculated the rate of change for the graph, kilometers per hour. But now we're just talking about slope. It's calculated the same way. Rise over run, or you could think of it as the change in y values divided by the change in x values. We've seen both of these before, where m represents the rate of change. Well, now m represents the slope of the line. It's the same idea. So here we have a ski hill. We want to calculate the steepness. That's the slope. So we're going to use our slope formula. Slope is rise over run. Well, the rise is 60 meters. The run is 70 meters. So 60 divided by 70, that's 6 over 7 as a fraction. Now notice this, meters divided by meters, well, those cancel each other out. So the slope doesn't actually have any units. It's not a rate of change, it's just the slope. So the slope here is 6 over 7. So here we have a line graphed, and we want to calculate the slope. So we can use slope is equal to rise over run. I'm just going to rewrite it in the other way. So delta y over delta x. Remember, delta y means the change in y values. Delta x means the change in x values. But we're talking about the same thing. It's rise over run. So we need points on this line. We need to find 2 points. So you can pick any 2 points that are easy to find. How about this point here and this point here? They're easy to locate. We can find the rise and the run between them, and we can calculate the slope. Remember to put your fraction in lowest terms, and if the denominator is 1, well, that's just a whole number. So in this case, the slope is 2. We'll do the same thing for this line. We'll calculate the slope. Here I've already indicated 2 points that you can use. So why don't you pause the video and try to come up with the slope of this line. Well, slope is rise over run, delta y over delta x. Change in y is -3. It's decreasing. And the change in x is 4. It's increasing. So we have a negative slope, 3 over 4. So don't forget about the negative. That's what I'm trying to get at here. For this last example, we're doing the same thing. We're calculating the slope of the line. So you could do it the same way as we did in the previous 2 examples, but I want to show you a slightly different way of doing it. It's more of using the coordinates of the points in your calculation. So again, we're going to find 2 points that are on the line. So let's do this one here and this one here. And we'll write out the coordinates of those 2 points. So now we're going to use the coordinates to calculate the change in y and the change in x. So delta y is the difference between our 2 y coordinates, and delta x is the difference between our 2 x coordinates. So if I take one of the y coordinates and subtract the other one, and do the same thing with the x coordinates, that's how I get my delta y and my delta x values. and that's how I calculate my slope. Things to keep in mind: if for my delta y, I'm starting with this one and subtracting this one, I have to do it in the same order when I'm calculating delta x. So I wouldn't do 4 minus negative 2 on the top and negative 3 minus 0 on the bottom. That wouldn't work. It has to be in the same order. If this is the first point I'm using, it has to be the first point I'm using in both the delta y and the delta x calculation. Otherwise, you're not going to get the correct sign on your slope. If you can double check your work, you would look at the direction the line is going. Well, it's going up and to the right. That's a positive slope. So if you ended up with a negative slope, you know you did it wrong, and you'll need to switch your signs around. Also, make sure you put your fraction in lowest terms, and if it's over 1, that's just a whole number. So you've seen a few different ways of calculating slope. You can do rise over run. You can find 2 points on the graph and find rise over run that way, or you can use the coordinates like I did in this example.